Hey guys, Harsh here, back in the video. So in this video I'm going to make this awesome firefighting robot which is ESP32 based and can be remotely controlled. So you can have some fun fighting the fire, or when you are not fighting the fire you can spray water on your family members, which I tried and it was awesome. So without wasting time, let's get started. Okay, so before I start this video, I just want to put out a quick disclaimer. So to control the robot, I'm going to use this controller over here, which I made in a previous video, and I thought that making this controller and the robot in the same video, that would unnecessarily increase the length of the video. So some of you might have a controller ready for your robots, or some might not have. So you want to know how to make this controller, just go to the link in the description. I have given the link on how you can make this controller. It is quite easy to make if you are familiar with the ESP and how the buttons and the different sort of things work with it. However, if you have seen that video, you would find that I had an encoder over here which is replaced now by a potentiometer. So let me just give you a quick overview of how this works. It is a 8-channel transmitter. So we have 4 channels over here for the forward, reverse, left and right motion of the robot. I have specifically designed this controller for this robot only. And then we have a joystick over here which will control our servo, or the movement of the water nozzle. So up, down, left and right, these are 2 channels. And then we also have a button if you hear the clicking sound. So this will be our fire button, so it will shoot out water when we press this joystick button over here. And then finally we have this potentiometer which will be used to control the speed of the robot, which is quite necessary because we are using just buttons over here, not this joystick. So that is quite a challenge. And obviously we have 2 batteries to power it up using this LM7805 voltage regulator over here. Also, to clear up any confusion, as you can see over here, I am using a external antenna over here so that I can get the maximum range out of this ESP module. But this step is not actually necessary. If you have just a simple ESP32 with the inbuilt antenna, it will just work fine. But if you want to know how to attach this antenna to the ESP32 board, again, link in the description, just check that video out. It is quite simple to do so. And at the back there you can see all the connections are made. So enough talking about the controller. Now let's start building our robot. So the first thing is actually so big that I have to zoom out my camera a bit. So as you can see, this is a tracked robot chassis, and if you look at the underneath, then you can see how the structure of it really is. So we have total of 4 motors powering it up, and these tracks right now I don't think you will find them anywhere because these are out of stock from almost every website that I know of. So let me just give you a brief overview of how the chassis works. So basically we have these 2 motors connected together driving this track over here, and these 2 motors are connecting together driving this track over here. If you remember, this is one of my testing chassis that I used for quite several of my controllers over here. Again, link in the description if you want to check those videos out as well. Now as you can see, I have some stands also over here. That's where my motor driver will go. Double-sided tape here for the servos and the nozzle and stuff. And here is the battery portion, and I think here I can put the water tank and the water pump. So I'll just figure that out. First step is to connect our motors to the motor driver. So as you can see, I have put a hole over here so that I can pass through these motor wires. For the left track, let me just pass them through this tiny hole so that I can easily connect them to the motor driver. So just like that, we have 4 wires poking out, 2 for this side and 2 for that side. And speaking of the motor driver, I'll be using this motor driver here. This is an L298N dual H bridge motor driver. So dual H bridge means it can control 2 motors simultaneously at different speeds or whatever you like. So as you can see over here, we have 2 terminals for the motor A output and motor B output. A terminal over here for the power connection. The leftmost terminal can, I think, take a supply up to 36 volts, and this will, I think, internally turn it down to 12 volt or something like that. The middle terminal over here is the ground, and the rightmost terminal over here is for the plus 5 volts output, so you can power up your microcontroller or whatever you like. The power from here is sufficient for the servos and the ESP32, so I'll be using this 5 volt supply rather than using a voltage regulator separately. So let's just put it in its place, which is right over here. I have placed some standoffs over here, as you can see, for the motor driver to go in. So it will just sit on it like this. Now we can go ahead and screw it in place. Only 2 screws for now. It is not that much big of a deal. Now we can connect our wires. So as you know, for this left track, these 2 wires will control the 2 motors on this side. So we'll connect them in the terminal just like so. And now we'll do the same on the right side. Now it is time to connect the terminals. So as I've said before, this is our positive 12 volt supply, so I'm going to just use this header pin over here and directly put it into the plus 12 volt supply over here. Now in total for this project you will need total of 3 ground terminals, one for the battery which is already there, second for the microcontroller power supply. So as you can see, I have soldered the wire permanently to this one, so this was there the whole time, and a third wire for our servo power. So all 3 will go into the terminal and we will just screw them down. Now the topmost terminal is for the plus 5 volts that will be powering up our microcontroller and our servos, so we'll need 2 wires for that. So in total we have connected 4 wires, and let me just segregate them out for you. So this wire over here, these 2 wires are our 12 volt supply input for the motor driver and subsequently powering up all the systems. Then we have these 2 wires over here, the purple one connected to the top terminal and the green one in the middle. This will be our power supply for the servos. And then finally the white one being the ground, yellow one being the positive power supply of plus 5 volts that will be powering up our ESP32. Now before we move any further on chassis, first we need to design our aiming mechanism. So for that I am using these gigantic 2 servos over here. These are all MG995 servos, so pretty high torque servos. You could get away by using this tiny servo over here, which is, as you can see, is absolutely small compared to this MG995. But the thing is that, let me just show you what the problem is. So this is my tube which will supply the water, and you can clearly see how small this motor is compared to this one, and these are not even the original servos, so I highly doubt that this motor would have enough power to move the nozzle around. It takes quite a lot of force to do that. So that is the reason why I opted out for these high torque motors. So what I'm going to do is just place one motor on the base just like so, and then on the top I will place my second motor just like this, and this will allow us to first pan the nozzle left and right, and with this motion over here I can just simply move the nozzle up or down. So this is just a basic pan and tilt functionality over here that you see. To attach them I am going to use this attachment over here, as you can see, which you will probably get when you buy these sort of motors. One will go on the motor just like so, as you can see, a bit offset over here, because then I can get zip ties around it so that I don't have to permanently paste this on the side of the body. So I might just do that. And now you can call this the sort of final form. The motor will be just placed like this onto the chassis, and that way it can rotate around left and right, and this motion will tilt up or down the nozzle. Pretty nice setup there. Let me just cut off these zip ties and then we'll mount it onto our chassis. So here is the mounted piece, and I have also secured it with zip ties over here at the base, you can see, with these white ones over here. So basically this will turn around just like this one, and if the nozzle is in place then it will just move up and down with this servo. So that now this is done, we need to solve one of our problems, which is the first problem that I have encountered here, which is the space. With this motor driver, the battery which will go right over here, the ESP32 board, the water tank and the pump, there isn't enough space for all of the components at the top. So what I'm going to do is just flip this board around and stick it on underneath here so that I can get a little bit more space here. What I'm going to do is just take these standoff, remove them, install it upside down, poke these wires through the hole. This will basically be the same connection, just that this motor driver will be underneath so that I can put some more components here. So let me just do that, and from there we will move on and install the other components. So now, as you can see, we have a bit more real estate to work with, and if you are wondering, this is how the board is installed. So the next step, I think we can mount the pump over here. So I am using this DC 12 volt pump. It has two nozzles over here. One is for the water in, so this will suck water, and the other nozzle is labeled as out, so this will throw out the water. This is, I think, a 3 liter a minute pump. I'm not sure about the volume, but that basically means that it can pump out 3 liters in a minute. So with this estimation, I think you can guess how far the stream would go. And I have done some pre-calculations, so I'm going to use this as a water tank. So in around 20 or 25 seconds, this thing can empty this whole container over here. So I think that's quite okay for a model of this size. And I actually forgot about that this also needs power, so I will need to go down again and bring out some 12 volt supply over here on the top, so that I can power the pump and add a relay also, so that I can turn it on and off again via the remote control. So I will place it just like here, and as you can see I have already drilled hole for the zip ties to go through, so that I can easily mount it just like there. So our pump is in, and as I have said before, this is the tube that I'm going to use. So the tube is actually a bit loose on this nozzle over here. So if I take this end and stick it on there, it is quite easy to take apart. So I have installed a zip tie over here. This basically reduces the diameter of the tube a bit and allows the tube to stick onto the nozzle properly. Now it doesn't come out quite easily, so you have to put a lot of force to take it out, but for the amount of pressure that this water will have, I think this is quite okay. And this tube will come around just like so and connect it to the servo motor over here. And as you can see, I have left quite a bit extra over here, and that is because of the movement on the servo over here. So this will move left, right, up and down, so we need some extra wire for that. So for the nozzle, I will be using this syringe which I have cut in half, and the pipe is actually the perfect length, so that it's stuck on there quite nicely, and this will just go on to the servo motor just like so. Secure it with some zip ties, and then we can have some high pressure water coming out of this nozzle over here. And as you know that this is a test body, so I have drilled quite a few holes all around the base over here, and this hole here is quite perfectly for the antenna to go through. It is not in the way you expect, because what I'm going to do is just poke this SMA connector through the body over here and install the antenna on the underside of the car. So this antenna that you see over here will be installed underneath, so it is quite hidden away from the normal perspective. Not going for stealth or anything like that, but this is the only space that I have for this antenna to go through, so I have no choice but to do that. Now we'll put in this single channel relay over here, and we'll connect the power to the left and the middle terminal. So if you know how a relay works, then you should know that these two terminals are not connected when the relay is turned off, but once the relay gets a high signal from its input pin, then these two terminals are connected together and the current passes through. So we will use that feature over here. I'm going to place it just over here, right next to the motor terminals over here, as you can see, just like so. And now we can connect the pins from here to the ESP32, which should be slightly at the back over here. Now I think I will need to drill another hole for the input pins for the motor driver to pass through this body and go inside the ESP32. So before we do that, let me just explain you how the motor driver will be connected to the ESP32. So if you flip the board around, now if you don't know the functionality of this motor drive, let me just explain you. So let's say we provide a positive voltage which is high to the input 1, then this will rotate clockwise, and if we supply a positive voltage to in2, then this will rotate counterclockwise. So that is basically the funda over here, and the same case on the left side. So input 3 means this will rotate clockwise, input 4 means this will rotate counterclockwise, or it's the other way around, maybe because of the polarity that is set over here. Now apart from those, they also have two additional pins, which is enable A and enable B. Now these pins control the speed of the motor, and because of the nature of this particular robot, the speed of both the sides should be the same. For that I am going to use this harness over here, which will connect enable pin A and enable pin B to a single pin on the ESP32, so that we can provide a PWM signal which will let this motor driver know on what speed the motor should run. So first let's connect it over here. These are the most extreme pin on both the left and the right side, as you can see. And if you buy this motor driver, you will get some jumpers on either end. So if the jumper is placed in, that basically means that motor will rotate in full power and you won't be able to control the speed of the motor while operating via a remote. But if you use this method, then you can set different speeds at different time whenever you like. Now let's connect the other 4 pins, which is input 1, 2, 3 and 4. So our red wire is our input 1, orange is input 2, yellow is input 3 and green is input 4. Now let's pass them through this chassis and connect them to our ESP32 board. Now it is time to do the step that I actually forgot, which is to connect the motor to the 12 volt supply via this relay over here. So I have, as you can see, red and black wire, and on the motor over here you can see there is a red dot over here, as you can see, which indicates the positive end of this motor. A pretty nice addition by the manufacturer, so it is easy to find out which way the terminals are. What I'm going to do is just cut this wire in half first and connect one end to the positive terminal first, because the switch should always be installed on the positive side. just like this. Now we will take the other end and connect it to the bottommost terminal over here. Now I will connect another wire to the middle terminal. So now let's connect the black wire to it as well, and then we will directly connect them to the 12 volt supply which is underneath the chassis over here. So now as you can see, we have two terminals, red wire being the positive 12 volt supply and black wire being the negative, and that will be directly connected to, let me just flip the board around and show you. So as you know that we have the power input right over here, the leftmost terminal and the middle terminal. So positive over here, negative over here. So we'll connect the red wire over here and the black wire over here. Now let's connect all our electronics to the ESP32 board, and I have saved this step for the last because as you can see there are a bunch of wires and they will require a huge amount of cable management, and I will add the water tank at the last and the nozzle over here as well. Let's start off first by connecting our speed controller. So as you know, this pin over here, the green which actually goes to yellow from here, is for the enable A and enable B, and I will connect it to pin number D5 which is right over here as you can see. So just like so. Now as for the input pins, the input one which is this red wire over here goes to GPIO pin number 33 which is at the top. As you can see there are a bunch of wires, so I have to move them around a bit so that you can clearly see how the circuit is. And don't worry, I will provide a circuit diagram in the description. So pin number 33 which is right over here, and the input 2 which is the orange wire goes to pin number 32. Now our input 3 yellow wire goes to the pin number 27 which is this one over here as you can see, and finally our input pin 4 will go to GPIO pin number 26 which is right next to the input 3, just like so. So now we have hooked up our L298N motor driver to the ESP board. Now let's hook up our relay. So if you have seen my relay video, you know that this only requires 3 pins which are positive and negative power supply and input signal. So we'll connect 3 wires to it. Now the VCC from the relay, which is this green wire, will go to the 3.3 volts output on the ESP32 like so, and the orange wire is our ground, so it will naturally go to the ground pin, and the input pin for it will go to GPIO pin number 4 which is right over here as you can see, like so. So now our relay is also connected, and the last thing to connect is our motors. So as you know, a servo motor generally has 3 wires which are brown for ground, red for positive power supply and yellow for the signal wire. So what I'm going to do is just put them like this together, and basically what I've done is created this harness over here so that I can supply power to both of them with the same pin. So as you can see, I have connected the ground wire, and remember the earlier wires that I connected. So the green is our ground for our positive 5 volt supply. I will connect it like so. Now again taking same type of harness, connecting the positives end of the servo motor to the positive 5 volt supply which is coming from the motor driver, just like so. Now also I should have probably done this at the start. We have this 5 volts connection that we actually need to power up our ESP32 board. So yellow is our plus 5 volt output, so that will go in the V in pin on the ESP32 board as you can see over here, voltage input, and the white wire being the ground, it can just go to the ground, just like so. Now let's connect our signal pins for the servo motor. So as you can see, the yellow wire I have left out. I will connect 2 separate wires for the signal input, just like so, and we will connect them to pin number 12 and pin number 14 on the ESP32 board, which is the remaining 2 pin on the left side as you can see over here. So one goes to here, pin number 14, and the other one goes to pin number 12, just like so. So now our connection is done. Now let's head over to our computer and program it accordingly so that we can get the best output. Okay, so here is the code that we are going to upload onto our ESP32 board to run our robot. And before you can copy this code, first you need to make sure that your Arduino IDE, that is this program over here, can actually upload the code to the ESP32 board, because by default it can only program Arduino board. So what you have to do is just go to files, click on preferences, and in the additional boards manager URL you have to paste this link over here. I will give it in the description, and once it is pasted there you can click on OK. Then go to tools, select the board and click on boards manager. This will open up this side window over here, or you can do that with just by clicking this button over here, so it will just directly open it. What you have to do over here is search for ESP32 and you will get these two options over here. So ESP32 by Espressive System, this is the one that you have to install. I have already installed it, that's why I am getting the remove button, otherwise you will get this install button. And once that is done, you can just restart your IDE and continue on with your code. Now coming to the code, as you can see, we are using three different libraries over here. First is the servo.h. Now this is not just any other library, this is the servo library for our ESP32. So to install that, all you have to do is just go to the libraries section over here and search for servo ESP32, and you will see this library over here. So just go ahead and install it. Right now it's saying update, but I won't do that right now. The thing over here is that the servo library, the extension for it, the way you define the servos is exactly as same as you do with the Arduino. So I mean, that's pretty nice. Then as you can see, we have the input 1, 2, 3 and 4 pins defined for our motor driver and to their respective pins that are connected on the ESP32 board. And then we have the speed over here, which is connected to pin number 5. This is our enable A and enable B pin on the L2, 9, 8 and motor driver, which are connected to pin number 5. Then our relay pin signal is connected to pin number 4. Obviously I have given this here because you can easily change according to your need. And then here you can see servo 1 is connected to pin number 12 and servo 2 is connected to pin number 14. Now just like normal servo library, we define two objects for our servo, which is S1 and S2. So S1 is our first servo, S2 is our second servo. Then what I have done over here is define the servo angle. So servo angle, at first both of them are 90. I need to center them first so that I can get the maximum range of motion from each of them. Now here is a bit confusing part that you may not recognize. This is actually for our PWM signal that will be sending via the pin number 5 for the speed. In Arduino, basically you can analog write this value directly to the enable A, enable B pin, but in the ESP32 you have to use a PWM channel in order to do that. So we have set the resolution to it, the frequency at 30,000, and this is basically just the properties for the particular motor driver that you are using. Now one thing over here is that you can see I have defined the PWM channel as channel number 2. In total, ESP32 board have 16 channels for PWM signal, that is from 0 to 15. But as you know, I am using two servos over here which also require a PWM channel, and the thing was I had this initially to 0 like so. What was happening was the servos were also on the same channel and only the motor driver was working and not the servo. So what I found out is that when you create the servo objects, it actually automatically assign the PWM channel to them. So servo 1 will have PWM channel 0 and servo 2 will have PWM channel 1. So the PWM channel for our speed control would be naturally PWM channel number 2. If you are using more servos, then obviously you need to increase this value. So let's say I am using 4 servos, they will have PWM channel from 0, 1, 2 and 3. So we'll need to define our PWM channel for the speed as 4. Now as you know, the ESP-NOW structure, we receive the data as a structure and the transmitter and the receiver structure should be exactly the same, which is over here the case. Now I'm going to just skip this part, I'm coming to that later. Now in the setup function over here, as you can see, we have the Wi-Fi mode and initialization of the ESP-NOW protocol, also the serial monitor over here. This is basically for debugging. Then we define the on data receive function over here and also the pin modes over here, as you can see, for our board. And as you can see, every single one of them is set as output because we are not receiving input on the robot. Then as you can see, we are basically doing the same thing, which is attach servo 1 to SEV1, which is I think 12 over here. If you go to the top, yes, you can see pin number 12, and same with the servo 2 SEV2, which is pin number 14. Now the write function over here, as you can see, it is basically the same again. So SA1, SA2, as you know, I have set the values at 90. This will center the servos, and then for the PWM output we define it just like this over here. This will be the same case for the servo, but that is taken care of by the library. Now as you can see, in the void loop function I have not written anything, and that is because of how the ESP-NOW library works. So for that, if we go to the part that we skipped, we have a void on data receive function. So whenever the ESP board receives the data, this whole function will be executed, and this basically acts as our void loop. So here, as you can see, we are writing the data.speed to the PWM channel number 2, which is defined right over here, as you can see. So data.speed can be ranging from 0 to 255, but from 0 to 160 I found out the motors don't even rotate, so why bother sending that much data? So I'm directly sending the values 160 and above and up to 255. And now here is our front, left and right motion for our motor driver. As you know, I have already said the input 1 and 2 are for our servo 1 and input 3 and 4 are for our left motor. So let's say we have this function over here. Input 1 is high, input 2 is low. This means the motor will rotate clockwise, and if the input 2 is high and input 1 is low, so the motor will rotate clockwise. Obviously you cannot set both of them high at the same time because that will create some sort of mess on the motor driver, so just don't try it. You can set them to low, that's okay, but do not set them to high simultaneously, and that is the case with all of the other functions over here. So this is just a basic left, right, back and front function, nothing too special here. Now here is our relay function. So for some reason I was getting the reverse value, so instead of 1 I was getting 0, so I have to reverse it again over here. So if the switch value is 1, the relay will be set at low, means it will not turn on, and that is the case when the button of the joystick is not pressed. And if it's any other value than 1, that is when the button is pressed, the board will receive a value of 0, so it will digital write the value of high to the relay, and the pump will turn on and spray the water. Now here, as you can see, we have the motions for the servo. In the joystick, as you know, we receive analog values that are ranging from 0 to 4095, and what I have done over here is that basically, let's say if I move, this is our x-axis, so if I move the joystick up, the angle which was originally set at 90 will be incremented by 1, and that value will be written to the servo. So let's say if I move the joystick up, the value that is going to be written over here will be 91, and if I keep the joystick in my up position, then the value will be keep on incrementing, and the servo arm will be going up and up and up. That is the same case with the down motion over here. So as you can see, it is -1 over here, so the value will be keep on decreasing, and make sure that that value doesn't go below 0. So I am using condition over here, so this code will only learn if the value of the angle is greater than 0. If it's 0, then it won't decrement it anymore, because then it will go to -1, -2, -3, and that won't do any good to us. Same with the y-axis over here, it is basically the same function. All you have to do is just change the analog values that you receive from the y-axis, because these potentiometer are not very accurate and sometimes you get some discrepancies. That's why I have given this code over here, so you can get the values of your x and y axis in idle position and when they are in movement, so that you can put these values accordingly. And this is basically how the code is going to work. Now all you have to do is just select your board and COM port. I am using the dev kit over here for ESP32, so I will select the dev module, select the COM port over here, click on OK. I have not connected the board yet, so that's why I didn't get in COM ports, and then you just click on upload over here and we'll upload the code to the board. So now let's head to our robot again and do the final steps and take it out for a spin. Now let's prepare our water tank, and as you can see, I am using this container over here, just a basic container, nothing too special about it. What I'm going to do is I am going to make sure that I am able to unscrew this lid over here, top it up and then screw it back on. And basically what I'm thinking is just making a hole over here for the pipe to go through, and the pipe length should be enough to reach the bottom of this particular tank. So the process would be like this. I will remove the pipe first, unscrew the lid, fill it up with water, close the lid back up, and then put the pipe back in just like a straw. So I have to make a hole over here, and the hole should be big enough for the pipe to fit through. So I have my solder iron right over here. So now let's make a hole in it. So as you can see, now if I try to fit the pipe, it is just big enough for the pipe to pass through, and I am looking just for that. This will also make it somewhat watertight and stop the water from spilling around. So that is good enough. Now we can just, let me just show you what it will look like. Screw the lid back in, push the pipe all the way down, just like so, as you can see. And once it's down, I can just connect it to the motor over here so that we can get a fresh water supply. Now let's cut this pipe to our length and mount it onto our robot. So I will just place down some double-sided tape and make sure that it is securely placed onto the chassis. Just like so. Now we can take this tube and put it in the input of the pump over here. So let me just figure that out, which one is which. Okay, so the bottom nozzle is our input, so this pipe will go just like this. Obviously we will need a zip tie for this one as well, because the diameter of this pipe is much greater than the diameter of the nozzle. Make it a bit tight. As you can see, it is now squished, and when we try to press this in, now it will stay securely in its position. Now this pump has its water supply. Now it's time for its output, so we'll connect another pipe to it, and this will basically just turn around just like this, and go to the servo over here, just like so. So the nozzle can go in just like this. Now what I can do over here is just use some zip ties and secure it in place. So this is our final robot. Now let's fill the water tank up, connect the battery, and let's take it out for a spin. So I am out here in the wild. Now let's top up our tank first. So we'll just unscrew the lid and we will fill it up right to the brim. And once you are happy with the fill, you can just take the lid and close it back up. Then you can take your inlet pipe and then just push it all the way down the container. So now our robot is ready to run. So let me just power it up. So first I will turn on my transmitter and then I will power it up. Now as you can see, it is powered on, and let me just test it first. Okay, yeah, so it is working. So let's test it out and take it a bit far away from here. So let's say that is good. Now we need a joystick to move the nozzle up and down, left and right, as you can see. Pretty nice. If you want to change the speed of the robot, you can do that by this potentiometer. Now it is quite slow, but you can see while turning it doesn't turn, so I have to increase the speed a bit and then try it again. Now let's finally fire it up. So we'll use the joystick button. You probably wouldn't catch that, so let me just back it up a bit and let's fire it away. So it's leaking a bit, but that's okay. It is not going anywhere near the electronics. And if I were to just do this, oops, okay, so as you can see, it works perfectly fine. Now let's check the maximum range for it. So I will bring this back over here. Now what I'm going to do is set the aiming at 45 degrees. That's the maximum amount of range that I can get from it. And once I am happy, I can just click on the fire button. And oh my god, so let's see how far it can go. I will press the button, and as you can see, it is going all the way to here. I think, not sure if it's visible on the camera, but you can clearly see the water coming out of here, right from there, as you can see. So I'm guessing about 3 meters of range you can get with this particular robot. So there it is, guys, your own firefighting robot, which can be controlled by the remote control. So thanks for watching the video, guys. Hopefully you like it. And now it is time to move on to my next project, which is sort of similar to this, but instead of fire, it will just spit out the opposite. So thanks for watching the video, guys. Hopefully you enjoyed it, and I will see you all in the next one.